us see today linear partial differential equations of higher order with constant coefficients. Okay, and we have two types of this linear PDEs of higher order with constant coefficients. One is for homogeneous, other one is for non-homogeneous. Let us see today homogeneous. Okay, so what is homogeneous equation? Let us consider this partial differential equation. A naught into dou cube z by dou x cube plus a1 into dou cube z by dou x square dou y plus a2 into dou cube z by dou x dou y square plus a3 into dou cube z by dou y cube equal to some or a function of x comma y. Okay, let us consider this the partial differential equation. It is partial differential equation because it has partial derivatives, right? And the degree of, you look at the order of each derivative. The order is third order derivative here, third order derivative, third order derivative, third order derivative. You can see that all the derivatives have same order. So equations in which the partial derivatives has same order, okay, occurring in it has same order. Okay, then we call it as homogeneous equation. Partial differential equation which has same order, right? All the derivatives have same order is said to be homogeneous equation. You look at the coefficients here, all are a0, a1, a2, a3 where all are constants. The coefficients are constants here. Okay, you look at the degree of the derivative, highest order derivative. Here luckily the order of derivatives are same. Hence the degree of each derivative is 1 here. The degree of this derivative is 1, right? So since the highest order derivative has a degree 1, right? We say it is linear equation. Here all are of with the same order, right? And hence you look at the degree of each derivative, which is 1 here. Degree is 1, right? 1. Hence it is linear equation. So it is linear equation, it is homogeneous equation, and it has constant coefficients, right? Higher order, maybe it is here third order, maybe we discuss up to fourth order derivative, okay? Fourth order derivative. So linear partial differential equation of higher order with constant coefficients. You know the meaning now, right? And so we have to solve this equation. We have to solve this partial differential equation and find a solution. So how can we solve this equation? Okay, let us see now. Let us introduce a new operator, capital D, which represent dou by dou x, and D dash, which is dou by dou y. Introduce new operators, okay? You can take Z common here. From all the terms, take Z common. And A naught into, since dou by dou x is D, this becomes D cube. D cube. Take Z common. A1, it is dou square Z by dou x square into dou Z by dou y. Right? Dou cube Z by, what is dou cube Z by? Dou x square dou y. See? Dou square by dou x square of dou Z by dou y. Which is, see, dou cube Z by dou x square dou y. And this is D square, this is D dash. Right? D square D dash, take Z common. Take Z common, D square D dash. Okay? So which is A1 into D square D dash. Take Z common. It is dou by dou x of dou square by dou y square. Dou by dou x is D. Dou square by dou y square is D dash square. Right? What is dou square by dou y square? Dou by dou y is D dash square. Okay. So D dash square plus A3 into dou cube by dou y cube is D dash cube. D dash cube. Take Z common, which is equal to R of x comma y. Okay. Let us now write this polynomial D in D and D dash as f of D comma D dash. Right? Whole thing into Z, which is equal to R of x comma y. This is polynomial in D dash, right? Which is function of D comma D dash into Z equal to R of x comma y. Okay. So now we have to solve this equation. We have to solve this equation. So listen here, we have already studied in ordinary differential equation, right? ordinary differential equation, similar type of problem. Similar type we have already solved. There, you know, when you solve, you will get the solution of y. Here, when you solve, you will get solution of z. And there we studied y is equal to complementary function plus particular integral, right? In ordinary differential equation. The same we have here in partial differential equation, right? When you solve this equation, listen here, you will get answer for z, where z is equal to CF complementary function plus PI particular integral. When you solve this equation, you will get answer for z. Z is the general solution, okay? Z gives the general solution. You know difference, complete solution, general solution, right? So Z is the, otherwise I tell you again while doing problem, I tell you, Z is the general solution, which is CF plus PI, okay? CF denote complementary function, PI denote particular integral, okay? So let us see what is complementary function. CF. What is complementary function? Complementary function. Okay, CF. To find CF, listen here, the right hand side of this equation must be 0. Right hand side must be 0. I tell you reason while doing problem. F of d comma d dash into z must be 0. We can find complementary function only when the right hand side is 0. Okay. So assume this is 0. F of d comma d dash into z equal to 0. Put d is equal to m and d dash is equal to 1. So here what we have to do is put d is equal to m and d dash is equal to 1. You will get equation called auxiliary equation. You will get equation called auxiliary equation. What is auxiliary equation? When you put d is equal to m, a0 m cube plus a1 m square plus a2 m plus a3. Because d dash is 1, right? Let us write what is the auxiliary equation. a0 m cube plus a1 m square, a2 m plus a3. Don't write whole thing into z equal to 0, okay? Don't write. Because listen here it is z, right? Z is equal to, I told you to find CF it must be 0. I tell you reason. See, don't write because we are going to find answer for z, right? You know when a into b is 0, we say a is 0 or b is 0. Since we are going to find answer for z, this cannot be 0. This cannot be 0. Hence this is equal to 0, okay? So have you understood why do we write here 0? Why do we write here 0? If we have some function of x comma y, if we have some function of x comma y on the right hand side, we cannot discuss. We cannot discuss whether this is the a into b is equal to some function. How can we say a is this? How do we get solution? Right? That's why we equate it to 0. And we find solution for this cubic equation. Being cubic equation, this equation will have 3 roots. 3 roots. Let us assume the roots be m1, m2, m3. 3 roots. Okay. So we do not know whether the roots are distinct or equal, right? So we have only 2 cases here. 2 cases here. If the roots are distinct, what is the case? If the roots are equal, what is the case? So it may be 2 roots equal or maybe all the 3 roots equal, right? Let us assume now the roots are different, 2, 3, 4, right? Different. Then the complementary function is, if the roots are distinct, complementary function is phi1 of y plus m1x plus phi2 of y plus m2x plus phi3 of y plus m3x, where phi1, phi2, phi3 are arbitrary functions. Since I said, right, when you solve, you will get solution, general solution for z. You know, we discussed general, we have already discussed general solution. So, that's why we have arbitrary functions here. Okay, we shall discuss more in the problem. So, these 3 are arbitrary functions. Okay, substitute m1, m2, m3, you will get one answer. What is case 2? If 2 of the roots are equal, but one is different. Let us write first arbitrary function for different root. Now let us write for repeated roots. m2x plus phi 3 of y plus m3x. To show these two roots are equal, let us write here x into. So you can say these two roots are equal, repeated, right? In order to show the roots are repeated, let us write here x. In case if all the three roots are repeated, first you write for first root, then x into second root, then x square into third root. That x square will tell you all the three roots are repeated. Okay. So if repeated root, this is the rule. If the roots are distinct, different, this is the rule. Okay. So these are the only two cases for complementary function. Let us discuss now particular integral. So the particular integral pi, the rule is 1 by function of d comma d dash into some r of x comma y. To find complementary function, right hand side should be 0. And to find particular integral, 1 by f of d comma d dash into some r of x comma y. Okay, the rule to find particular integral. Okay, next it is see this r of x comma y. There are some types of r of x comma y, function of x comma y. Type 1, r of x comma y is e power ax plus by. Okay. Then what is the rule to find pi? F of d comma d dash into e power ax plus by. The rule is put d is equal to a, d dash is equal to b. Put d is equal to a, d dash is equal to b. Then pi is 1 by f of a comma b into e power ax plus by, which is the answer. Only when the denominator is not 0. After replacing d by a and d dash by b, denominator should not be 0. Okay. So which is our first type. What is type 2? R of x comma y is equal to sine of ax plus by or cos of ax plus by. Okay. Pi is equal to 1 by f of d comma d dash into sine of ax plus by. The rule is, here we replaced even for the letter d dash. Here the rule is put d square is equal to minus a square, d dash square equal to minus b square, d dash equal to minus ab. A is the coefficient of x, b is the coefficient of y. Find a square, include negative sign. Find b square, include negative sign. Multiply a and b, include negative sign. So this is the rule for sine of ax plus by or cos of ax plus by. Okay. So you learn rule and let us complete it. Let us discuss more in the problem. Okay. Type 3. And you should know one thing. Not only simply sine of, cos of. In case if you have sine A, sine B form, cos A, cos B form, right? Cos A, sine A, cos B, cos A, cos B, all comes under this rule. Okay. Not only simply e power ax plus by. Hyperbolic functions and constant functions all comes under this type 1. E power ax plus by, hyperbolic function and constant function. All comes under type 1. Okay. Here type 2. What is type 3? If r of x comma y is equal to x power r, y power s. Polynomial in x and y. If you have polynomial in x and y, our pi is 1 by function of d comma d dash x power r, y power s. This is the rule. Symbolically we write pi. Here what we do is, that type 1 we have some rule, type 2 we have some other rule, type 3 we have to use binomial expansion. 1 plus x whole power minus 1, 1 minus x whole power minus 1. So we have to use binomial expansion to do this type. Okay. We shall discuss in the problem. What is type 4? See, if r of x comma y is equal to product of two functions. One is e power x plus ax plus by and some function of x comma y. Product of two functions where one must be exponential. Okay. If one must be exponential, other one is maybe trigonometric or polynomial. Other one can be trigonometric or polynomial, but one must be exponential. Product of two functions. Symbolically, we write pi as f of d comma d dash e power ax plus by function of x comma y. The rule is put d is equal to d plus a, d dash is equal to d dash plus b, then keep exponential term constant. Pi becomes, take exponential term constant, d become d plus a, comma, d dash become d dash plus b, function of x comma y. This is constant now. How do we proceed? If it is trigonometric, sine of ax plus by, cos of ax plus by, proceed by type 2. If it is x power or y power s, proceed by type 3. Okay, you will get answer. This is type 4. Next we have type 5. But type 5 is r of x comma y is equal to, it is y cos x or x sin y, right? Or x cos y, y sin x, etc. Product of two functions. One is trigonometric, other one is algebraic or, right? Algebraic. So this is type 5. Let us discuss the procedure in the problem, okay? We shall go to problems now. Solve the equation. It's a third order differential equation. Right hand side is 0. Okay, right hand side is 0. Okay, solve this equation. You know z is equal to cf plus pi. And to find cf, right hand side must be 0. It is already 0. And pi is equal to 1 by polynomial d dash into some r of x comma y. There is no r of x comma y, so pi is 0. There is no pi here because there is no r of x comma y. So this problem has only cf. Okay. Okay. First let us check to find cf, right hand side is 0. It is 0. Very good. So the rule, answer starts with put d is equal to m, d dash is equal to 1. We get equation called auxiliary equation, AE, which is m cube plus 2m minus 2m square minus m minus 2. If you write whole thing into z equal to 0, then a into b is 0, a is equal to 0 or z is equal to 0. Z will not be 0, right? Because we are going to find answer for z, which will not be 0. So z equal to 0 is not possible. Hence this is equal to 0. Okay. So if you substitute, you will get whole thing into z equal to 0. But we will not consider z. Okay. Solve this using calculator. And you will get 3 roots, right? Use calculator to get answer. Otherwise use synthetic division method. Coefficient of m cube, m square, m constant term. So let us choose what it can be. I start last, it is minus 2, right? It's 2. I try with 1 here. 1. Synthetic division. Oh, luckily 1 is answer. Trial and error method, right? It is trial and error method. If it comes 0, it is right. Okay. So among 3 roots, we have identified first root. Let us see second root. Again synthetic division. It is plus 2 here. I do with minus 1. A trial and error method. I am choosing minus 1. Oh, luckily 0. Minus 1 is also the root. So being 2, it is, I try with minus 2. It is also a root. So we have 3 roots, 1, minus 1 and 2. Right? So I write order, m is equal to, the 3 roots are minus 2, minus 1 and 1. 3 roots. Right? Let us write now CF. What is the rule for CF? We look at the roots. If all the three roots are distinct, the rule is phi 1 of y plus m1x plus phi 2 of y plus m2x plus phi 3 of y plus m3x, which is the rule. So m1 is minus 2, m2 is minus 1, m3 is 1. If you want, you can change m1 as 1, m2 as minus 1, m3 as minus 2. If you want, you can change. Okay? You can write phi 1 of y plus x, phi 2 of y minus x, phi 3 of y minus 2x. If you want, you can change. Okay? This is complementary function. All the three roots are distinct, and hence this is complementary function CF. And right hand side there is no function, so there is no particular integral. The general solution is Z is equal to CF plus PI. There is no PI, CF alone. Y minus 2x, phi 2 of y minus x, y plus x. This is general solution. Why do we say this is general solution? We have three arbitrary functions here, and the order of differential equation is 3. If the order of differential equation, order of differential equation and the number of arbitrary functions are same, then the solution is general solution. This is 3 here, and the order of the derivative is also 3 here. Since they are same, the solution obtained is called general solution. That's why it is general solution. Okay. So we have found answer for the question. Let us do another question. Solve this equation. So let us now introduce D is equal to dou by dou x, the operators dou by dou y, D dash for dou by dou y. Take Z common from this. This become D square. This is dou by dou x, dou by dou y into Z. So D dash with 5 plus 6 into D dash square, whole thing into Z equal to e power x plus y. See, the coefficients are constants here, and the equation is homogeneous equation, everywhere second order. Homogeneous equation, constant coefficients, right? And the degree of each derivative is 1 here. So linear equation, right? So this is the question, this type of questions we are discussing now, right? Okay. Now we have to find CF. So you know, to find CF, right hand side must be 0. Right hand side must be 0. So that, listen here, why do we say right hand side must be 0? If you consider with function right hand side, you cannot discuss whether this is 0 or this is 0, right? That's why right hand side must be 0 to find CF. Okay. Put D, now write auxiliary equation. D is equal to M, D dash is equal to 1. M square minus 5M plus 6 equal to 0. This is auxiliary equation. When you put D is equal to M, D dash equal to 1, you will get equation called auxiliary equation. Whole thing into Z 0. When A into B 0, A is equal to 0, B is equal to 0. This is it. Listen here, what I am saying is M square minus 5M plus 6 into Z equal to 0. Right? When A into B is 0, A is 0 or B is 0. This cannot be 0 here. This cannot be 0 because we are going to find Z where Z is complementary function plus particular integral. It cannot be 0. Hence this is 0. This is 0. Okay. So in order to discuss this, we say right hand side must be 0. Otherwise, how can we discuss this type, right? So you consider C, to find CF, right hand side must be 0. Okay. Now let us find roots. Quadratic equation, it is easy to do, right? When you multiply, you should get 6. When you add two numbers, you should get 5, minus 5. There are two roots, quadratic equation. 3 2s are 6, right? 3 2s are 6, minus 3 minus 2 minus 5. So it's your choice. You can use even calculator to find answer. So the two roots are 2, 3 or 3, 2. Two roots. Since both the roots are distinct, CF is equal to phi 1 of y plus m1x, phi 2 of y plus m2x, right? m1 is 3, m2 is 2, or m1 is 2, m2 is 3, your choice. y1 plus y plus 2x, 2, 3, your choice here, right? Which is CF. Okay. Next to find PI. What is PI? 1 by function of d comma d dash into r of x comma y. R of x comma y is e power x plus y. So what is PI? 1 divided by d square minus 5d d dash plus 6d dash square e power x plus y. 1 by function of d comma d dash into r of x comma y is the rule. This is our d dash, right? Function of d dash. Okay, what is the rule? This is type 1. E power ax plus by. Type 1. A is coefficient of x, which is 1. B is coefficient of y, which is 1. So the rule is put d is equal to a, d dash is equal to b. D is equal to 1, d dash is equal to 1. A and b are 1 here. So pi is equal to 1 by d is 1, d into d dash, which is 1 into 1, 1 minus 5. D dash is 1, so which is 6 here, 1 square is 1, e power x plus y. This is 6 plus 1, 7 minus 5, 2. So the answer is e power x plus y by 2. Hence the general solution is, question is solve. So you will get solution CF plus PI. You know CF answer is y plus 2x, phi 2 of y plus 3x, e power x plus y by 2. This is CF answer, PI answer. It is general solution, right? General solution, because it has two arbitrary functions and the order of differential equation is also 2. The solution is called general solution, right? Solve d cube minus 3d d dash square plus 2d dash cube whole thing into z equal to e power 2x minus y. It is homogeneous equation because the order of derivative is 3 here, d into d dash square 3 here, d dash cube 3 here. Homogeneous equation. So let us first find the CF. We know to find CF, right hand side must be 0. Otherwise we cannot discuss, we cannot find the solution for quadratic or cubic equation, right? Right hand side of those equations must be 0, right? 0. Let us put d is equal to m, d dash is equal to 1. We will get auxiliary equation m cube minus 3m plus 2 equal to 0. You know you should not write ez, right? I need not discuss. Okay. So this is what you can use calculator to find roots of this equation, or you can do manually using synthetic division. Coefficient of m cube, m square, m constant term. M square, there is no m square here. Okay. So let us try with the trial and error method. Let us try with 1. Synthetic division. Next, what it can be? Trial and error, right? Let us discuss with again 1. You can use calculator, right? 1 plus 1, 2 here. Oh, luckily right. Since plus 2, I should do with minus 2. 2 minus 2, 0. You need not do this method, synthetic division. You can use calculator to find roots, okay? 1, 1 minus 2. Solving, you will get roots the roots are 1, 1, minus 2. 2 repeated roots and 1 non-repeated root. 2 roots are repeated here, right? Let us write CF. So phi 1 of y plus m1x, phi 2 of y plus m2x, phi 3 of y plus m3x. This is CF for non-repeated root. Since 2 of the roots repeated, let us write, listen here, m1, m2. We consider m1, m2 the repeated root. Your choice. You can consider m2, m3 repeated root. Your choice, okay? I consider m1, m2 repeated root. To show it is repeated, I should write x. X shows the roots repeated twice. X square shows the roots repeated thrice. If 3 roots are repeated, you have to write here x square. So the answer is phi 1 of y plus x into phi 2 of y plus x, phi 3 of y minus 2x. Next, let us find the particular integral pi. The rule is 1 by function of d comma d dash into r of x minus y. R of x minus y is e power 2x minus y. What is the rule? We have to put d is equal to a. A is the coefficient of x. D dash is equal to b, where b is the coefficient of y. Put d is equal to 1, d dash is equal to minus 1. What is our pi? 2 into 2 into 2, 8. 3 into 2 into minus 1, which is plus 3 into 2, 6. Right? Sorry. 3 into 2 into minus 1 the whole square, which is plus 1. So 3 into 2, 6. D dash square is equal, d dash is equal to minus 1. Minus 1 the whole cube, which is minus 2. Minus 1 the whole cube is minus 1, right? Minus 1 into 2, minus 2. Okay. Which is 8 minus 8. You can see 1 by 8 minus 8, 0. So the rule fails, right? So when you apply rule, denominator comes 0, hence the rule fails. So what to do when rule fails? It's very simple. In order to say rule fails, put x in the numerator. How do we say here? In order to show roots repeated, we write x, right? Similarly here, in order to say the rule fails, put x in the numerator. Differentiate this denominator with respect to d partially. You know partial differentiation. When you differentiate with respect to d, d dash is constant. Differentiate d cube, it is 3d square. Differentiate d, take these two constants outside. Differentiate d, which is 1. So you have to differentiate it with respect to d, keeping d dash constant. This d dash is constant. When you differentiate, it will become 0. 0, which is e power 2x minus y. Now use the same rule. We are going to apply the same rule. Put d is equal to 2. 2 into 2, 4 into 3, 12. D dash is equal to minus 1. Minus 1 the whole square is plus 1. 1 into 3, 3. So x divided by 9, right? We have got answer divided by 9. Okay? Which complete problem. So when the rule fails, so this x shows rule fails once. In case if it fails again, you have to put another x, which will become x square. That x square shows rule fails twice. Okay? So rule fails once. And then see, this is the answer. Let us write the general solution is Z is equal to CF plus PI. Write the answers of CF and PI. Problem over. Okay. So we shall discuss type 2 problem in the next video. Thank you.